Let me ask you something real quick. Why is it that even now, with all the talk about decentralization, most serious GPU workloads still end up on the same big cloud providers? I've been thinking about this a lot, and the answer is not as exciting as people want it to be. Decentralized compute sounds great on paper. A global pool of GPUs, no central gatekeepers, cheaper access for everyone. In reality, though, most of what exists today is either too messy to use or too fragile for actual production work. Setup is annoying, reliability is inconsistent, and the developer experience usually feels like you're debugging the infrastructure instead of your own code. So it's not a surprise when people fall back to AWS, GCP, or Azure, not because they love them, but because they work. You click a few buttons, spin up a GPU, and it runs. Simple, predictable, expensive, but predictable. That trade off is basically the whole game right now. And this is where Ocean Network starts to feel interesting to me. Instead of asking developers to completely rethink how they work, it plugs into the workflow they already use. You stay in your editor, VS Code, Cursor, whatever. You write your code, package it as a containerized job, and send it off. The system handles finding GPUs across a distributed network and running the job wherever capacity exists. What you get back is just the result, not infrastructure management, not server babysitting, just clean output. And yeah, it still leans on familiar ideas like pay per use compute, but the important part is how it changes the experience. You're no longer thinking in terms of which instance should I spin up or how long am I paying for idle time. You're just running jobs. And you know what? Let me just show it to you. So to start, we open up the official Ocean Network website at oncompute.ai and we click on the run a job button as seen, and that takes us over here. And now over here you need to create an account and you can use your Gmail for this. It takes less than a minute. Upon creating the account, you'll be given a wallet, right? You'll be given a wallet address and you can fund that wallet with USDC. You can fund that wallet with USDC from MetaMask or wherever you hide your hard earned coins. I've already done all of that, so we'll proceed. Um, as you can see, the workflow is clear: environment, resources, payment, finish. So we're going to start with environment. And in the environment section, as you can see, there's a pool of GPUs that we can select from, and each of them comes with their own price tags. So I'm just gonna go for something simple to demonstrate. I'm gonna keep the compensation as USDC, although you can switch it over to CompY. But I'm just gonna keep it with USDC because I've already funded my wallet with USDC. So we're just gonna click on this. And for the resources now, okay, so I'm gonna select the GPU, just one of it. I only need one, I'm not that rich. I'm gonna keep the cores the way it is. I'm gonna keep everything else the way it is. RAM, wow, 40 gigs of RAM. That's generous. And I'm just gonna change this to minutes and swap it over to 1 minute, just testing out things. And as you can see, wait, yeah, as you can see, for 1 minute, the estimated total cost is 0.041 USDC. And we're just gonna continue. And now with all that done, yeah, I need to deposit. So amount to deposit, as you can see, has been provided for us, although that number seems strange, but let's go with it. So we're just going to proceed. I already have something in my wallet, as you can see. So deposit, waiting. Okay. Alright, so deposit was successful, and now we just need to authorize. Okay, max log count, everything looks good. Smart workers. Alright, so let's authorize. Alright, so it was authorized, and we're gonna generate a token here. And next we're just going to, you can either choose an editor, but I have VS Code installed. But for my vibe coders out there, there's always Cursor, Windsurf, and Anti-Gravity. So, but I'm just gonna go with VS Code because I already have that, and I'm not a degenerate. So we open up VS Code. Alright, so now in VS Code, to proceed, you actually need to install the Ocean Orchestrator extension, and I've already done that, but if you haven't, you just come over here and you search for Ocean Orchestrator, and this should be it. And as you can see, I've already installed this for myself, so just go ahead and install that for yourself. And you come over here to where the Ocean Orchestrator widget is, you click on it, and as you can see, you can go through a lot of this, and you can run a compute job, create a new project folder, or select an existing one that contains the code that you want to execute. And you can also configure persistent storage. All of that is beyond the scope of this particular video, as I'm just trying to get you to have a feel of the land. And you can read and go through the Ocean Orchestrator documentation on VS Code. Yeah, you can go through that, and basically that's it. It's that easy and that simple to do things with Ocean Orchestrator. In upcoming videos, I will be showing you how to actually run a job and how to pull out the results. And also another very interesting thing with Ocean Orchestrator is the compute to data approach that they are using. That's specifically Ocean Network, which basically allows your code to run in an isolated container and only the results are returned. So the data stays sealed if you are concerned about data privacy and all of that. I know I am. The bigger picture here is not really about cheaper GPUs. It's about whether decentralized compute can finally match the simplicity that made centralized clouds dominant in the first place, without inheriting all the cost pain that comes with them. It's still early, but this feels closer to the right direction than most of what I've seen so far. It's not revolutionary, but it's a better way to actually use compute without fighting it every step of the way. And that's the important takeaway from all this.